Unit 4.6, complete the square. So in this unit, we're going to learn how to solve equations by completing the square and learn how to rewrite functions by completing the square. In the last unit, we learned two methods to solve a quadratic equation. They are, first, by graphing. Second, by using the zero product property. And in this section, we can learn how to solve a quadratic equation by completing the square. So these are the three methods to solve quadratic equations. And when we talk about rewriting functions, we can learn how to change the standard form of a quadratic equation, which is ax squared plus bx plus c, to a vertex form, which is y equal to ax minus x whole square plus k. So we're going to rewrite the function in standard form to vertex form by completing the square. Before we learn the concept of completing the square to solve a quadratic equation, let's learn solve by finding square root first, because it helps us understand more about how to do the completing the square. Here's the first example. What is the solution of this equation? So when you look at the equations right here, you know this is quadratic because you got the power 2 right here. And if you rewrite the whole thing, this one is the a term because it's ax squared plus, we don't have bx, so this one is the constant c. I'll call this one a c as well. But you know, in the standard form, we have ax squared plus bx plus c. And in this case, we don't have any x terms. We just have two constants. So we write the whole thing from here to here by doing subtraction of 10 on both sides, so that we can rewrite the whole equation in terms of ax squared equal to c, because 46 minus 10 is equal to 36. And then we try to isolate x squared by dividing both sides by 4. And then we end up getting x squared equal to 9. But when we try to solve this equation, we are not looking for x squared. We are looking for the value of x. In order to get rid of the square, we do the inverse or the opposite of square, which is the square roots. So we take the square root of x squared on both sides. In this case, when we take the square root of a square, we end up getting x. And we take the square root of 9. Watch out, we can have plus and minus 3. Remember, you can always check it. Look, if you have 3 whole square, of course you got 9. And if we have negative 3 square, we also get 9. So that's why that x could be positive 3 or negative 3. And of course, we can always do the check work by putting 3 back to this original equation to check it. So I want to check for, say, 3 whole square plus 10, is it equal to 46? And of course it is, because 3 squared is 9, 9 times 4 is 36, plus 10 is 46. Let's check the value of x when it is equal to negative 3 whole square plus 10. Negative 3 whole square is still 9, so we do have a value of 46 when x is equal to either positive 3 or negative 3. Here's the second example. We are basically doing the same thing. The first step is to rewrite it into ax squared equals c form. So in this case, we know a is 3, c is -5 and 25. So we're gonna add 5 on both sides, which you have 30 right here for c value, and this one's gone, so we have 3x squared equal to 30. Now we isolate x squared by dividing by 3 on both sides. So you end up getting x squared equal to 10. We're going to doing the same thing. We're going to take the square root of x squared, and we're going to take square root of 10, which will give you this answer. Now we can make use of the skills we just learned from solving quadratic equation by finding square roots to solve a perfect square trinomial equation. But of course, before we learn how to solve a perfect square trinomial equations, you have to know what perfect square trinomial is first. Here are 4 examples of perfect square trinomial. They're trinomial because we got 3 terms. So to factor this expression, we can make use of the sum of factors strategies. So the factors of the c value here is 1 and 1. And the sum of this 1 and 1, the factors of 1 is 2. So we're going to have x plus 1 times x plus 1. It's the factor form of this standard form. So right now we can simplify it to change it to x plus 1 whole square. That's what we call perfect square. The next lines, we're doing the same thing. The factors of 4, we make use of 2 and 2, because 2 times 2 is 4, and the sum of these factors is 4. So we end up getting x plus 2 times x plus 2. Now we have x plus 2 whole square. So this is a perfect square, and that's why we call this one perfect square trinomial. We're doing the same thing here. The factors of 9, 3 and 3, and the sum is 6. So we have x plus 3 times x plus 3, which is the factor form of this trinomial. So we end up getting x plus 3 whole square. For the same reason right here, we're going to end up x plus 4 times x plus 4, and then we have x plus 4 whole square. And this one is what we call a perfect square trinomial expression. Now we put together the skills that we learned from solving equation by finding the square roots as well as the perfect square trinomials. Here's an example. So this one is a perfect square trinomial expression equal to 25. So this is a perfect square trinomial equation. As what we have just done in the last PowerPoint slide, we know this one is equal to x plus 2 whole square, and then equal to 25. Now we use the concept of square roots. We take the square root of both sides. And because we take the square root of this whole square, we take away the square right there, and then the square root of 25, we got plus and minus 5. Now we can split up to 2 equations. So x plus 2 equal to 5, or x plus 2 equal to -5. So we solve this equation. We find x is equal to 3, or x is equal to -7. Here is an example of how you do completing the square. The first thing you need to remember is, in order to do completing the square, you have to remember this little formula of b over 2 whole square. b is referring to the x term of x squared plus bx plus c. This is the b. In this example, they ask you to complete the square for these quadratic expressions. So if you line them up with the standard form, you're going to have x squared minus 10x. So the value of b is -10. So when we do the completing square, we are basically applying the formula of b over 2 whole square. In this case, -10 is the b, that's why we put it right here. And then -10 over 2 whole square, you got -5 whole square, which is equal to 25. And then if you add this term here, you are going to have x minus 5 whole square. This is how you complete the square for a quadratic expression. and we need this skill to help us to solve a quadratic equation. Now you have to combine all the skills that we just learned in this unit to solve a quadratic equation by completing the square. Here's an example. We are going to solve this quadratic equation. First, we just have to isolate all the x terms on one side by subtracting this constant on both sides. That's what you have right here. In order to do completing the square, the coefficient of the leading term has to be 1, and in this case we have 3. Therefore, the first thing we have to do is to change the coefficient of the leading term. This is the leading term because it got the greatest power, to 1. All we need to do, just divide the whole expression by 3. So I'm going to divide the whole thing by 3. That's what you have right here. And you end up getting x squared minus 4x is equal to negative 2. Then we're going to apply the formula of b over 2 to find the value that we need to do the completing the square. In this case, we have negative 4 over 2 whole square because b is negative 4. If you cannot see it, I'm going to write it right here for you. Ax squared plus bx plus c is the standard form, and if you line them up, x squared minus 4x, so b is negative 4 right here. And after you simplify b over 2 whole square, it will give you 4. And then we add 4 to each side because this is an equation. The reason we add 4 in this side is because we want to get the perfect square. And if you use the sum of the factor strategy, you know this one's x plus 2, should be x minus 2 times x minus 2, which will give you x minus 2 whole square. And then once we have the perfect square, we can square root the whole thing to get rid of the square. And that's why you end up x minus 2, and this one is plus and minus square root 2. And we solve for x, then we know the solutions is x equal to 2 plus or minus square root of 2. You can always check your result by using a calculator and put this value back to the x value here, and then you can check if it's equal to 0. If it's equal to 0, then you did solve the equation. Another important function of learning completing square is to convert the standard form of a quadratic equation to vertex form of a quadratic equation. The reason we do that is because it's easier for us to graph a quadratic equation in vertex form instead of standard form. So let's learn how to do that. Here's an example. We are going to convert this standard form to a vertex form. The standard form is y equal to ax squared plus bx plus c. The vertex form is y equal to ax minus x whole square plus k. hk stands for the vertex. The value of a, the sign before a, h and k, they all related to the transformation of the quadratic equations. So once we have the vertex form, we can easily sketch a graph of the quadratic function. Now let's see how we're going to convert the standard form to the vertex form. Here are the steps. First, remember the b here is equal to 4. We have to use the little formula b over 2 whole square to do the completing the square process right here. We're going to add b over 2 whole square in order to make this whole expression into a perfect square form like this. But since we add plus 4, we have to do a minus 4 right here, so that the function itself hasn't been changed at all. because plus 4 minus 4 equal to 0, and it go back to the original equation, x squared plus 4x minus 6. The reason we add 2 squared is because we want to make it to a perfect square. Now we simplify this and we got negative 10. Once we have this, we know the vertex gonna be negative 2 and negative 10 because this is h and this is k. The reason is negative 2 is because the vertex form is x minus h whole square. Since we have plus 2 here, we can convert to x minus 2. That's why x is negative 2. X minus 2 basically is x2 whole square. The y-intercept is 0, negative 6. We don't have to do anything to find it because in standard form, it basically tells you what the y-intercept is. Because y equal to x squared plus 4x minus 6. So when x equal to 0, you know the y-intercept is where x equal to 0. Then you have y equal to negative 6. So the standard form tells you the y-intercept. And of course the vertex form tells you the vertex. Now if you have this vertex form, you know the vertex is going to be negative 2 and negative 10. And because A is 1, it didn't do any vertical stretch or compressed. And because the sign before A is positive, so there's no reflection. And that's why you have a graph like this. You can always check with your graphing calculator to make sure you get the right answer.